Thank you, Kim. I appreciate it. And thank you, Greg, for organizing this wonderful conference. It's really a pleasure to be here. This is the changer.
Oh, sorry.
Can't get along without that.
No. All right.
So now for something completely different. I'm going to be talking about attention control groups in behavioral intervention research. I have nothing relevant to disclose. Now, over the years, many behavioral trial proposals have been rejected for what is called failure to control for attention. And also many published behavioral trials and manuscripts submitted for publication have been condemned for this alleged sin as well. What are we talking about when we're talking about controlling for attention? An attention control group is an ambiguous label for a variety of conditions that supposedly control for attention, placebo, and or other non-specific sorts of effects. And there are really 4 different perils of using attention control groups. One is misspecification of the purpose of the trial. Another is a mismatch between the purpose of the trial and the purpose of the control group. Third is design failure of the control group, and a fourth is implementation failure of the control group. So let me briefly run through what I mean by that. Misspecification of the purpose of the trial is a common problem. It's often the case that we don't think through the purpose of the research that we're doing adequately. We don't really think carefully enough about what we're doing, why we're doing it, what the goal or the aim really is, and why we're doing what we do. And oftentimes, the rush to control for attention fills the gap that's left behind when we fail to think through the purpose of the trial adequately. And incidentally, I'm going to symbolize each of these by a scary, perilous sort of thing. So the first one is a fire-breathing dragon. The second is a scary great white shark. And this is the problem of a mismatch between the purpose of the trial, assuming that the purpose makes some sense, and the purpose of the control group. And so in this scenario, if you have a comparator that's designed to control for attention, placebo, or non-specific effects, doing so contradicts or defeats the purpose of the trial that you had set out to conduct your research for. The third, symbolized by the Grim Reaper, is a design failure. And this is a problem in which the control group is designed in a way that does not serve its own intended purpose. It doesn't do what the investigator means it to do. And the fourth, also represented by the Grim Reaper, is an implementation failure. The control group is implemented in a way that defeats its own purpose. Now, I don't have time to go through in depth all of these. So I'm going to focus today on the third one, the control group design failure, and some implications of that. So to think about this, let's look first at how drug trials are designed and conducted. Randomized, double-blind, placebo-controlled drug trials are the gold standard efficacy test for drugs, as we all know. And they're also one of the major inspirations for why so many of us have used attention-controlled designs in our behavioral research over the years. The history of how we got to this point is more complicated than that, but one of the main factors has been sort of emulating the way things are done in pharmaceutical trials. And in order to understand where we went wrong in borrowing from drug trials, let's look at how drug trials are designed. So the primary purpose of a standard drug trial is to determine the efficacy of a particular pharmaceutical chemical, right? And the drug versus placebo design is very familiar to all of us. We have two different arms that you might be randomized to, and what you get in those two arms superficially is indistinguishable. They both look the same. But this is really where our trouble begins, because this is not really a drug versus placebo design. That's a misconception. Why do I say that? Well, let's look at what creates the placebo and nocebo effects in a drug trial. Nocebo, of course, is the side of this where side effects or adverse effects can be generated by an inert substance, so to speak. Well, these effects are basically formed through expectancies that are acquired through processes of learning, conditioning, observational and verbal learning, and they're activated by two sources of stimuli, one being intrinsic, and these are the characteristics of the vehicle. For example, the color of the capsule makes a difference in how people respond to it. Whether it's a pill or a syringe makes a difference, and in certain cultures it makes more difference than others. Then there are also extrinsic stimuli, and when you sign up for a trial, there is informed consent. So you're told what the drug is, what the fact that you may or may not get the drug, you may get placebo. You're told what the side effects may be, the risks, etc. This is all taking place in a medical environment, so you have some generic expectation about something that they're giving me is going to have some sort of effect on me. The fact that you're in a randomized trial is very important, because if you were given a capsule without being told anything about it and without having any reason to believe that it might contain a chemical, then it wouldn't have the same effect as it does when you know that you're in a trial. And incidentally, knowing how many arms are in the trial makes a difference. The probability of getting the real drug or the probability of getting the inert one makes a difference in people's expectations. So in a double-blind, placebo-controlled trial, both groups are exposed to identical intrinsic and extrinsic placebo and nocebo stimuli. In other words, both groups get the placebo, right? The difference is there's a chemical hidden inside of one of them, and there's just inert powder hidden inside of the other one. That's the difference between the groups. It's not drug versus placebo. And that's where our problems really begin. Because the typical conception of how these studies are designed is drug versus placebo, but the reality is closer to this. Both groups get a placebo. They differ in terms of whether they get the chemical or not. But it's actually more complicated than that, because the participants in a drug trial also receive a form of attention that's known as clinical management. And so the design really is chemical plus placebo plus attention versus inert filler versus placebo plus attention. And so essentially drug trials, even though they look simple, they're just capsules or pills, they're actually complex interventions that have three distinguishable components. And the participants rarely know whether they're in the chemical or in the inert filler group. Now, side effects, a lot of people think that the group that gets the most side effects, they must know that they're in the drug group because they're having side effects. Ain't necessarily so, because nocebo effects can be very powerful. People can get remarkable side effects from inert substances. They're not actually getting it from the inert substance, but they're reporting side effects and experiencing things that are hard to explain. So it doesn't necessarily give the group away. Now, occasionally in some trials, there may be a problem with the blind. For example, if the chemical has a very bad taste, sometimes the blind can be problematic. But usually in most trials, most or all participants remain blind. And under this condition, the chemical component is completely dissociable from the other two components. And so here's what the design really does for us. Both groups get the identical placebo. They both get identical clinical attention. What they differ in is in the active ingredient, the chemical. That is the difference between the two groups. And it's a beautiful design. It works really well for isolating the effect of the chemical, which is what the pharmaceutical trials are all about, figuring out what that chemical is doing as opposed to what everything else that goes along with it is doing. And dissociability of those components means that the presence or absence of the chemical has no effect on the placebo and attention components. They're identical in both groups, and removing the chemical doesn't alter the placebo and the attention elements as long as the participants know that they might be receiving the chemical. Again, it's the fact that they're in a trial. It's not just that they're handed a capsule or a pill, it's that they know that they might be getting a real drug as opposed to an inert substance that matters. Now, dissociation doesn't necessarily mean that the effects of these components are 100% additive. The effects may overlap to some extent. For example, we know that some of the brain circuitry that subserves the placebo effect is also involved in analgesia. And so, in a sense, the placebo effect may steal some of the analgesic molecules effect or vice versa. So the effects are not necessarily going to be fully additive. But nevertheless, the dissociability of the chemical from the other components makes it possible to test whether the chemical has an effect above and beyond placebo and attention. Unfortunately for us, in most behavioral trials, these components are not cleanly dissociable. And there are several constraints on the dissociability of these components in our trials, namely unblinded participants, interacting components, and entangled components. So the participants in most of our trials are unblinded. We can only do single-blinded trials. We can't really pull off double blinding in most cases. And thanks to informed consent, the participants know which group they're in as soon as they're randomized. They also know which group they're not in, right? They know what they're missing, and they know what they're getting. And they may have very different expectancies about the two different groups, even if the investigator tries to equate or equilibrate the expectancies. Don't forget, expectancies are in the eye of the beholder, and we can try as investigators to influence the expectancies of our participants, but we can't dictate them. We can't guarantee that people are going to have the same expectancies about very different kinds of conditions. In fact, we can usually assume that no matter what we do, they're going to have somewhat different expectancies. So some of the components of a complex intervention may interact with other components. And there are a couple of different kinds of ways this can happen. One is a synergistic interaction in which the combined effects are greater than the sum of the parts. So some of the ingredients are sort of promoting each other. But there can also be an antagonistic interaction in which one component counteracts the effects of another component so that their combined effect is less than the sum of the parts. And so these sorts of interactions, they're hard to divine in the first place, but so we don't always know whether or not they're going on. But the fact that they are possibilities makes it more difficult to isolate the effects of whatever we think are the active ingredients of our interventions, namely the behavioral equivalence of the chemical in a drug trial. And then there's entanglement, which to me is one of the biggest problems. When the components of a complex intervention are deeply entangled, the qualities, the qualitative nature of the intervention may be very different than the qualities of the isolated components. And the intervention can't be dismantled without obliterating its compound effect and unmasking or revealing the effects of the components. So let's try an analogy with a dietary trial. Let's say you want to study the effects of a high sodium diet, and so you randomly assign participants to a high sodium diet or a low sodium diet. And the high sodium diet develops hypertension, and the low sodium group lives happily ever after. And so nowadays we don't really need peer-reviewed journals, we have Twitter. And so the results of the study get broadcast to the world as new study proves that a high salt diet is bad for your health. That's what we glean from that. But then you have critics who come out of the woodwork and say, but wait a minute, your trial had a serious confound. Salt is sodium chloride, and your trial doesn't tell us whether it was actually the sodium that caused the hypertension. It could have been the chloride. And you didn't control for chloride, so shame on you. You didn't do your trial right. And so we're going to do another trial to satisfy the critics. And in this trial, we randomly assigned participants to a high sodium diet with plenty of salt, NaCl, or a high chlorine diet, plenty of Cl and no Na. And the high sodium diet group, once again, develops hypertension, but elemental chlorine is toxic. So instead of putting salt on your dinner, you're putting bleach on your dinner. And everyone in the chlorine control group dies en masse. And so the tweet this time is, new study proves that a high salt diet saves lives. Now, this is an absurd example, but according to the traditional wisdom, that latter trial was the more rigorous of the two because it controlled for this supposed confound. It doesn't seem like a confound in this analogy, and it really isn't because it's an essential entangled part of salt. You're controlling for part of salt, and that's where things go wrong here. So it's analogous to many situations in which we try to control for attention or placebo effects. Now, the active ingredients of most behavioral interventions, at least ones that are delivered by human therapists, it may be somewhat different for some of the technological interventions where there's no human interaction, but at least for human-delivered therapies, the attention and placebo elements are deeply entangled with the other ingredients. And so in most cases, I would argue that the attention and placebo elements can't be extracted without changing their qualities. But there's also another problem that occurs when we try to extract those components. And that is that there is no such thing as bare, naked clinical attention in a clinical trial. You can't just sit there and stare at the patient and shower attention on them. The attention has to be delivered in the guise of some sort of therapeutic activity, right? This is my dog, Maya, and she gives me lots of attention, which I find therapeutic. But as a therapist, I can't just sit and stare at my patients and think that that's going to be a good thing. In fact, it could have more nocebo than placebo value to do something like that. So you have to wrap the attention in some sort of intervention. And in drug trials, that clinical attention, as I mentioned, is delivered in the form of a necessary, purposeful, and credible activity, namely clinical management. It's something that's necessary in a drug trial. You're monitoring signs and symptoms, tracking compliance and addressing non-compliance, addressing other clinically relevant issues like other collateral medical problems that may emerge during the trial and so forth. And that activity does not differ between the groups. But the activity in the attention control arm of a behavioral trial is typically an artificial, clinically irrelevant quasi-intervention. And by clinically irrelevant, I mean it's more often than not something that you would simply not give and is usually not given to people in actual clinical settings. It's made up, it's artificial, it's not something that's really clinically appropriate. But it serves as a delivery vehicle for the clinical attention. And because of entanglement, the attention that it provides inevitably differs qualitatively from the attention that the experimental intervention provides. And in many trials, it differs quantitatively as well. And this sort of impinges onto the implementation problem. Just as an example, in many times although the attention control group is supposedly dressed up to be, like a real intervention, the patients catch on kind of quickly and get sick and tired of it after a few sessions, and there gets to be higher attrition in that group than in the other group. And so quantitatively, there is less attention actually in the control group than was intended, and less attention than the experimental group gets. So going back again to the drug trial design, this design beautifully isolates the active ingredient, the chemical. But when we, by analogy, use attention control designs in behavioral interventions, this is what happens. So let's say I want to test cognitive behavior therapy for some problem, and I think up an attention control condition that involves some sort of educational something or other, which is a common thing to do, some sort of health education or something that's sometimes has something to do with the problem, sometimes it's really almost irrelevant to the problem that's being treated. So here what you have is the active components of CBT, such as cognitive restructuring, behavioral activation, and so forth. The placebo aspects of the CBT intervention, which are really closely connected to what you're doing in CBT as a therapy. And the kind of attention that you're giving the patient is very much connected to the kind of therapy that you're doing. So over here, you create a quasi-intervention, some sort of bogus education condition as a bogus education condition as a vehicle for delivering attention and something to wrap the placebo in. And these elements, the placebo and attention, are tied to the educational intervention. So they're different qualitatively and often quantitatively from what is happening over here. So in effect, this design does not isolate or deconfound the treatment's active ingredients. So that's what I am referring to as a design failure. It simply doesn't work. So with few exceptions then, we can't dismantle behavioral interventions in a way that offers everything to one group and everything but the active ingredients to the other group. And that's unlike drug trials. It doesn't mean that dismantling designs are always futile in behavioral research. It's possible in some situations to dismantle dissociable elements. They're not always 100% cleanly dissociable, but close enough. So a good example of this is eye movement desensitization reprocessing, which has been a very controversial kind of therapy for PTSD. And there have been any number of studies now that have randomized people to everything that you get, all of the exposure and everything else that you get, minus the eye movements, and then the other group gets the rapid eye movements. So you compare those two, and you can see whether or not the eye movement component makes any difference. And I have to say, too, there are lots of situations in which superiority to placebo is an important question. It's a lot more important in some scenarios than others. Like, I would say the kinds of interventions where it's maybe less important are ones that are everyday, common sense, well-grounded in behavioral science and the science of behavior change, things like exercise interventions. The placebo aspects of that are a little less important or controversial, perhaps. But then there are all sorts of controversial non-pharmacological interventions, techniques, procedures, devices. And for many of these, it's often possible to devise a reasonably valid placebo control for them, unlike the placebo elements of human-delivered behavioral interventions. So, for example, sham acupuncture has been used in many situations as a placebo control for real acupuncture. And it's entirely possible to do a trial like that. Very different than trying to create an attention control group for a CBT trial. So, again, the perils that I'm talking about don't preclude the use of valid placebo controls in NPI trials if they fit the purpose of the trial and if that purpose makes sense. That's not always the case, but when it is, it's a legitimate thing to do, I would say. So I've only discussed one of these four perils, but I hope this alone is enough to give you some pause, some reason to question our entrenched tradition of attention controls and behavioral research. So often the case that people propose other kinds of designs for very good reason, and they run into reviewers that just are hell-bent on insisting that you have to control for attention no matter what, even if it doesn't make any sense, and even if they're satisfied with attention control designs that don't really serve their intended purpose. So I'm kind of on a crusade to try to get us out of the habit of just thinking that attention controls are better than other alternatives and that we always have to use them and that there's something wrong with your trial if you don't. There are often good reasons not to use an attention control condition. But this raises the problem of, are there any better alternatives? And I would say that the alternatives depend first and foremost on the purpose of the trial. There's a close relationship between what you're trying to accomplish in a trial and what comparator you're using. Those are intimately related. So I just want to leave you with a few recommendations. There's a lot more to be said on this subject, but first of all, don't try to control for the ingredients of an intervention, for the intrinsic entangled components of an intervention. Don't control for that. It's like controlling for the chloride in salt. So don't even try. If the question you're asking is about the efficacy of an intervention package as a whole, compare it to a clinically meaningful alternative, like in the trials that you've heard about, right? Don't compare it to an attention control condition. Compare it to something clinically meaningful, even if that means usual care in a setting where many people don't get much in the way of care. They're not getting much or very adequate treatment. If that's the clinical reality, then that in its own way is clinically relevant. There are other kinds of clinically relevant comparators as well, but they're all better alternatives than trying to dismantle an intervention for the wrong reason at the wrong time. And so I would urge you to carefully consider whether, when, and why it's necessary to establish superiority to placebo and or attention aspects of a behavioral intervention. Thank you.